So, hello everyone. This is the fourth lecture of engineering economics. Today we will study what are the cash flows and the life cycle costs. So let's start this lecture. So in the introduction part, the initial cost of an energy system, or you can say engineering system, uh, will be cost of buying plus cost of installing. Here the annual cost that we've already studied, like maintenance cost, manpower cost, taxes, cost of fuel, repayment of loan, that we've already studied in the first or second lectures. Now we have some economic criteria that we can do our analysis. One is simple payback period, net present value, benefit to cost ratio, life cycle cost, and annualized life cycle cost. That's called ALCC. So let's start with a simple payback period. Simple payback period is the number of years in which investment pays to itself. That is, in how much year our investment we will get back. In how much year time, we can say time we will get our invested money back. Okay. So if we take an example, an energy auditor recommended additional insulation on wire. The cost of insulation is 6 lakh rupees. It is estimated that installing the insulation will result in saving of 5,000 liters of light diesel oil priced at 60 rupees per liter. What is the simple payback period? So for this case, we can we can calculate the simple payback period, like in just a minute. So in that case, the our initial investment is 6 lakh rupees. So we can calculate SPP is equal to 6 lakh rupees upon annual savings. Annual savings is that is saving a 5,000 rupees per liter. That is saving 5,000 liters. Sorry. 5,000 liters, and 1 liter cost is 60 rupees. So how much saving we are having that in 1 year? 5,000 into 60, that is 3 lakh rupees. So now it can easily, simple payback period will be 2 years. Similarly, a 5 kV PV system installed on an office building roof cost 4 lakh rupees. It helps to saving 7,200 units electricity annually. If the cost of electricity is 8 rupees per unit, to calculate the payback period. So now it's a simple again the same case. Simple payback period will be, initial investment is 4 lakh rupees. It helps to save a 7,200 units. So per unit cost is 8 rupees. We can calculate this. That will be 57,600 rupees annually. So in that way we can calculate 4 lakhs divided by 57,600. It will come around 6.94. We can approximately say the payback period will be 7 years. Okay. Now you got how to calculate the simple payback period. So let's continue to the next thing, that is discount rate. Discount rate, it compares the investment today with the, it compares investment today with expected future benefits. So we can say discount rate represent how money flow, how money today is worth more than in future. It does not have any theoretically correct value. So we can calculate discount rate by discount rate for the future is like value in the year one and the if value in the present value. Suppose we are calculating the discount rate for the year 2020 in year 2020, so it will be remain same. But for the year 21, the value in the year will be one only. That will be one only, and the present value will be 1 upon 1 plus discount rate. That will be like this. And if we will calculate 2020 plus some kth year, like then we can we have to the formula will be 1 upon 1 plus d to the power k. In that way we can calculate what is the present value of money we are. So let's say example, there's a company that is having a initial capital cost of C naught, and it has to pay there is no possibility of borrowing or lending capital. A number of project is available internally for investment, but suppose for each project they are having a capital money of C. So now we have to calculate what is the annual return that they are getting. So suppose that C naught is the initial capital that is given. You have to calculate the That is our initial investment. These are the returns. That is for the year, for the return for the year 1, year 2, year 3, and simultaneously for the year n. So each year return we can calculate, like for the year 1, P1 will be 1 plus A, that is the return value, A upon 1 plus D to the power 1. P2 we can calculate A2 divided by 1 plus D2 D to the power 2. Similarly, for the year n, we can calculate from this formula summation of AK, that is a kth year, that is in the subscript, and 1 plus D to the power K. So in that way, we can calculate what is the our returns in the kth year. Here P is the present value of all cash flows. This is for the all cash flows, and this is for the each year. So simultaneously, if you want to calculate for the all years, we can calculate from this formula. Now, let's do a next thing is the capital recovery factor. Capital recovery factor, we can say CRF. CRF is annualized investment corresponding to the initial investment. Means how much money we have to invest annually. It it depends on equipment or project life. That is N. It depends on the discount rate. So CRF will be A by P, that is equal to D upon 1 plus D to the power N divided by 1 plus D to the power N minus 1. So now from this formula also we can get CRF is a function of discount rate and project life N only, where D is the discount rate, N is the life. So let's take an example for that. Calculate CRF considering an investment in an equipment with a life of 10 years at a discount rate of 12. So CRF formula here here D was 0.12 and is 10 years. So from the CRF formula, we can calculate what is the CRF formula, that is D 1 plus D to the power N divided by 1 plus D to the power N minus 1. Now CRF will be 0.12, that will be 1 plus 0.12 1.12 power 10, and also 1.12 to the power 10 minus 1. So now CRF will be 0.177. So what does it mean? It means 17% of money we are investing. Sorry, all of the money that we have invested, we are getting 17% annually. This implies that if we have made an investment of 1,000 rupees, 1,000 rupees today, it is equivalent to the annual investment of 177 rupees over the lifetime of the period. So now let's move on to the next thing, that is net present value. So let's So in that case, we can say like a capital recovery factor. Just let me like, uh, show you one more thing about CRF. CRF is the like we can calculate what happens if we increase the discount rate to 30%. Like suppose in that case we have increased the discount rate to D will be 30%. Then that if you will calculate, the CRF will be 0.323. That means more discount rate we have, the initial that we have to invest 300 to 20 323 rupees annually. That means if the discount rate increases, the our investment per year will be increased. Suppose that discount rate will be to 20%, then then that if the D will be, suppose the D will be 20%, then CRF, if you will calculate from the similar formula, then D will be 0.134. Then that means our initial investment that we are making is 177 rupees, and here in that case is 323. Here we are only paying 134 rupees. That means we have to choose this option. If you are having an option of 12%, 20%, and 30%, we have to choose a 20% option, because that shows we have to pay annually like only 134 rupees if you want to make an investment of 1000 rupees over the period of 10 years. Let's move on to the next thing, that is net present value and benefit to cost ratio. Here, net present value is the present value of benefits minus cost. Its unit is in rupees, sorry, its unit is in rupees, or we can say $1,000,000 or some million rupees. NPV can be calculated as summation of AK upon 1 plus D. That is the present value of benefit that we already calculated in the previous slide, that is P. So what will be NPV? NPV will be P minus C naught. So that P will be this formula. Now benefit to cost ratio will be, these are our benefits, these are our costs. So B by C will be benefit to cost ratio. For being a viability, the benefit to cost ratio will always should be more than 1, because if that benefit to cost ratio will be less than 1, then there will be loss always, and we don't want to make any loss for any industrial purpose or a personal purpose also. So that is the basic criteria for consideration. Benefit to cost ratio should always be, we should not select this. Benefit to cost ratio should always be more than 1. So next thing is life cycle cost. Life cycle cost is present value of all the expenses related to specific option during its lifetime. That means present value of all the expenses related to all the options during its lifetime. That means LCC, we can say it LCC also. What we will have in that is initial cost, and one thing is with the benefit. That means initial cost plus the total value of that project or product, that we can say that. And where that ACK is annual cost or expenditure in the kth year, that we have already studied in the previous slides. Now the annual capital cost ACC, that will be C naught into CRF. CRF we know how to calculate. If we will have C, then we can easily calculate what is annual capital cost. Now, what is annualized life cycle cost? Annualized life cycle cost is annual cost of owning and operating a equipment. And then annual cost will be the sum of annual capital cost, annual cost of fuel, and annual cost of operation. Suppose we are having a machinery. What is, how can we calculate it? How much? What is the value of that machinery? So we have to calculate the what is the annual capital cost that we have made, what is how much fuel it is consuming, and how much is the operation and maintenance. Here, if we will do that, ACC will be C naught into CRF. ACF will already been will be given, and AC will be given on the basis of how much the operation and maintenance cost. Now let's take an example. Uh, the cost of an standard AC is 10,000 rupees, and its expected electricity sorry, and its expected electricity consumption per year is 450 kilowatt hour. The cost of an energy efficient AC of an same capacity will be 450 kilowatt hour, and with the same feature is 10,500 rupees. That is costing more. For the same load, the annual electricity consumption is expected to 450 kilowatt. So here we are seeing that the initial cost is more, but it is consuming less electricity. The life of refrigerator, both of the refrigerator can be taken as 10 years. Now we have to calculate the life cycle cost for the discount rate 30% and the electricity price is rupees 5 per kilowatt hour. Now from the initially by seeing it, we can say we should choose it. That is like the initial cost of refrigerators is low. We should choose this. But let's calculate what would be beneficial for us. So first here D is 30%, or we can say 0.30. Life is given 10 years. So we can calculate CRF. CRF is 0.3, 1.3 to the power n, that is 10. Here also 1.3 to the power 10 minus 1. The CRF, if you will calculate, that will come around 0.323. Now, life cycle cost, if you will calculate, that will be initial cost, that is T naught plus life cycle cost for the refrigerator 1, or we can say AC1, that is a AC. For the 1 plus the cost of fuel, can calculate it as a 10,000 rupees, plus how much unit it is considered consuming. It is consuming 450 units, and the cost of per unit will be 5 rupees, and we have to divide it by the CRS. Then the life cycle cost will be 16,966 rupees. Similarly, if you will calculate the LCC for the AC2, it will be 10,500 rupees plus 400 into 5 divided by CRF, that will be 16,692 rupees. So we can say this refrigerator is costing more, we should choose this only, because although it is consuming less amount of electricity and but the initial cost is having some more effect. It is some minute difference. If we will say, then we should choose option 1. Now let's take an example for doing the all the calculation that we have learned. A small remotely located company is considering a power supply options for the base station. Suppose the company is located in some remote area and it needs some power supply, and if it is saying that its annual power required on an average basis is 2 kilowatt, and while some if that demand is higher, then they are consuming the peak power is 5 kilowatt. So they have two options for consideration. One is the diesel generator, and second is the PV power plant, that is a photovoltaic power plant. So we have to choose what option will be more viable for them. Let's say the configuration given for the diesel generator is it is having a rating of 5 kilowatt, cost is 1.7 lakhs, life is 10 years, and diesel generator operating cost is rupees 20 per kilowatt hour, and non-fuel and operating and maintenance cost is 0.3 per kilowatt hour. Now for the photovoltaic plant, it is having a 12 kilowatt of module costing 6.5 lakhs, life is 25 years, and batteries cost because for the storage purpose, because the sunlight is not available throughout the day, we have to store the energy in the batteries. Then the batteries cost will be 4.5 lakhs, and it has a 1 day autonomy of 50 kilowatt hour. That means it can store up to 50 kilowatt hour, and the life of the batteries is 5 years. Now the balance system cost like wiring and some other installation is 3 lakh rupees. It's having a warranty of 10 years, and operation and maintenance cost is 0.25 per kilowatt hour. Now assuming the discount rate of 30%, compute the cost of electricity generated in both the cases, and what is the simple payback period for the incremental investment in B. That means we are investing some increasing amount of money, that is 6.5 lakhs, that is way more than the diesel generator. What should be what is viable for that PV plant, how much money that we are paying extra, we can that's calculate the simple payback period for that. Now let's solve this. So let's first take a case of case A, that is diesel engine. Its capital cost is given 1.7 lakhs. Operating cost will be fuel cost plus non-fuel operation and maintenance. Average is given 2 kilowatt. So the annualized, in that case we have to calculate annual electricity generation. that we will need average. That will be remain same for the both the cases. So annual electricity generation will be 2 into 8764 kilowatt hour. So how we have calculated this? This is we need electricity for the 24 hours and 365 days, and for the that is for the capacity of 2 kilowatt. So for the if we will calculate for the 2 kilowatt, that will be 17,520 kilowatt hour of electricity is needed annually per year. So energy input that we have to give, that is 7,560 into 360 kilojoule. If you will convert it into the kilojoule, it will come as 63.1 gigajoule. And energy input, if you will give energy input, that is energy output. Energy input we have to give is 17,560, or we can say 63 point divided by 0.35 kilojoule. That will be around 180.2 gigajoule, or we can say 180 into 10 raised to power 3 megajoule. Here we have calculated the energy input. That means how much input we have to give to generate that power form, because these things we have calculated from like diesel generator efficiency. We have assumed the diesel generator efficiency is 0.35. In that way, if that is 35% efficient, then we have to give that much of amount of energy to diesel, or of diesel we have to use, and we will then we will get the this amount of energy. So in our initial thing, these things we can calculate for getting some more practical knowledge, means how much energy is we are getting. So let's continue this. So the annual diesel that will be used is 180.2, and the calorific value of the diesel is 42 kilojoule per kg. It is 10 raised to power 3. Then that whole thing will be 4291 kg. That is around 4.29 tons. Let me rewrite it in a better way. I think will create confusion. That will be 180 into 10 raised to power 3 into calorific value, that is 42 kilojoule per kg. Here kilojoule will cancel out. That is megajoule, and that will also be megajoule. So annual cost of diesel will be, we are considering it as a 70 rupees if taking a older rates. That will be 3 lakh rupees. approximately. And non-fuel and operational non-fuel and O&M cost is 0.3 into 17520, that is 5256 rupees. But total operating cost will be total operating cost will be 3.05 lakhs. Now, if we see the questions that is already given in the question, that is like if we will calculate the operating cost from this will come around, sorry, I think here I've made some mistake. These things have not been given in the question. We can solve it in an easier way. Let me recalculate it. So just a minute. These things I've done for the actual calculation, but if the questions is not telling you about the anything that is calculated, needs to be calculated, then we can directly calculate the things. Now, so you know how the diesel energy generated, how can we calculate the in a broader way? So let's come to the question then. Now it tells that it is having a diesel generator having a initial cost, that is C naught 1.7 lakh rupees operating, that is a purchase cost. Life cycle is 10 years, rating is 5 kilowatt, and operating cost is rupees 20 per kilowatt hour. So we have to go, uh, uh, consider the capacity of 5 kilowatt, then operating cost will be 20 into 5, that is 100 rupees. Just a minute. Just a minute. Let me cross check it. So let's start. Let's start with the what is the annual electricity generation, that is around 2 into 24 into 365, that is 17520 kilowatt hour. Now let's consider the case 1, that is diesel engine. Diesel engine initial cost is 1.7 lakhs and is already given 10 years. D is the discounted 30%. Operation cost we can say OC will be 20 kilowatt per hour. So we can calculate operation cost will be 20 into 17520. That will be around 3 lakh 50,400 rupees. That we have calculated from the a vast calculation of the calorific values also, that is already same. And annual that is the first cost. Second cost will be annual O&M cost, that is 7,520 into point 3, that is 5,256 rupees. Now the annual capital cost will be C naught into CRF. And CRF, if you will calculate for the D and N, that will be 0.323, because we have already calculated in the previous example, that is same. Now we can calculate SEC will be 1,70,000 into 0.323, that is 55,000. Now let's take ALCC of diesel engine. That will be 1 plus 2 plus option 3. That will be 4,10,656 rupees. Now we can calculate the cost of electricity generation. That is total cost upon number of units produced. That will be 4,10,656 rupees upon 1,75,000. Sorry, 175 17520. That will be around 23.44 rupees per kilowatt hour. So that is our cost of electricity that we can generate from the diesel engine. Similar thing we can calculate for PV plant. So here T is given 0.30 and is given 25 years. So now CRF we can calculate here. We can see that is given for the solar module only. If module, if we will see for the batteries, discount rate is 30% and life is 5 years, that is same. And if we will calculate for the balance system, discount rate is 30% and life is 10 years. So we have to calculate here 3 CRFs with having a different discount rate and the life cycles. So in that way we can calculate. Here it is given like non fuel operation and maintenance cost is 0.23 per kilowatt hour. If you will multiply by 520 kilowatt into 0.25, that will be 4380. That is our first cost. Second cost will be ACC, annual capital cost in the PV. Here we have to calculate the cost of module plus cost of batteries plus cost of remaining system. Here cost of module is 6,50,000 multiplied by CRF if we will calculate for 0.3 and 25 years plus 4,50,000 into CRF of 0.3 into 5 plus 3 lakhs into CRF of 0.3 into 10. If we will calculate this, then CRF for the first case will be 0.3, CRF for the second case will be 0.411, and CRF for the third case will be 0. Third case will be 0.323. Here, sorry. If we will sum this up and calculate, that will be 4,77,000 rupees. Now we can calculate the cost of electricity, and now we can calculate the overall cost. That is second. Cost will be first plus second. That is 4,81,380 rupees. Now in the similar way that we have calculated the cost of electricity generation for PV, that will be 481,380 upon 17520. That means that is an unit number of units that we need. That will be 27.45 rupees per kilowatt. And in the diesel case, it was around 23.44. In the PV case, it's 37. So that is the it's some more cost. So now if we will calculate, now we have to calculate the incremental cost. The total cost of PV is 6,50,000 plus 4,50,000 plus 30,000. That is 30,000. Sorry, 30,000. That will be 14 lakh rupees. Now, if we will see the incremental cost, that is how much money we are investing more than the diesel engine. That is, diesel engine is costing only 14 lakh minus 1 lakh 70,000 rupees. Incremental cost is 12 lakh 30,000 rupees. So we can calculate the simple payback period for that incremental cost. Initial investment is 12 lakh 30,000 rupees, and annually we are saving 3 lakh 50,000 rupees. From where it came? It is the fuel cost, because fuel for the PV is free. We can take it as an annual savings that we are getting. So we can calculate that is 3.5 years. So if we are having two options like PV generator and solar PV module, we should choose PV panel, because it is giving only 3.5 years simple payback period. Now, in this example, you have calculated all the things that we have learned in the today's lecture. That is how, what is the ACC, what is the ALCC, how the CRF is calculated. So similarly, this kind of example you can practice from your own. I will refer you some books for that. You can calculate it, and you can practice the this example also for getting some more knowledge. Thank you. We will meet in the next class.